Hello, my name is Michael Alien, and this is my ECS 1021 bonus project, and I chose the grand challenge of making solar energy more economical by implementing a solar tracking system. So I'm just going to quickly explain to you the logic of my code in a general sense. So once you start the main thread, it's going to check the status of the button, and an event listener is checking the state of the button, and then it'll handle it and send it to the while loop that's after it, which will check the voltage across the potentiometer, and whilst it's greater than 0, it'll run the parallel thread and the main thread. So after that, the LDRs will begin to take light readings, and then based off of the difference from the X and Y direction, it will move left or right or up or down. Then display those live readings and ratings and the system status on the OLED display. Now, while the system is running, for the second thread, we will scan for the user's input, and depending on what we get from the user's input, it'll either manually move left, right, up or down, or it'll resume automatic tracking. So here I'm just going to give you a quick demo of my code. So first, when it starts, it's going to ask you to press the button, and it's going to bring up the hash map, the plots for the hash map. Then it's going to start taking readings from the light, and you see I can move the light, and it's just going to follow the light. And it'll do this forever until it stabilizes when it balances the light intensity across all 4 LDRs. Then I'll just turn it off by turning the potentiometer all the way to 0 volts. So for learning outcome number 3, where I use my hash maps, I mapped different numbers to certain movements. So 1 moves to the left, 2 moves to the right, 3 moves up, 4 moves down, and 0 resumes the automatic tracking. So here I'm just going to show you how the manual control works. So you can see here, I'm just basically showing you the numbers that I'm putting in. For some reason, I'm not sure why those 3 4s didn't all work. Only 1 did. But the rest works, and then it went back to 0 and started tracking again. So here I just want to show you what's being displayed on the OLED. So it's just voltage, current, and power, and all those different values are calculated based off of 5 volts being equal to an irradiance of about 1,000 watts per meter squared. And it's basically the purpose of displaying this is so that the user can see if this product is beneficial to them or not, and if it's better than, to prove that it's better than a stationary solar panel. So for the first learning outcome, it's just these simple tests are just going to check to see if the servo is going to try to turn more than it can, which could end up damaging the servo or just messing up the code. So for the third unit test, it checks to see if there is a non-integer or string input that's being inputted when you're trying to do the manual control. And the fourth one, ChatGPT gave it to me. It basically just simulates light sensor readings and verifies that the system can move left when the difference is exceeding that threshold. And for the fifth learning outcome, I organized all my classes similarly to how I did my plant watering system. I kind of organized them in a way that all my physical components have their own class, so that all my methods, all my attributes, and all my code, my comments, I know where everything is, and it just makes it more organized and clean.